Let's have a look at this event. In the cross-section view, there doesn't seem to be much going on in the muon chambers or in the hadronic calorimeter, but as we can see if we zoom in more, there are some energy deposits in the electromagnetic calorimeter, which could come from electrons, positrons or photons, and there are some charged particle tracks in the tracking detector. To work out what these are, we want to find out if there are any charged particle tracks pointing towards them. We've got a lot of tracks to deal with here, so let's go to the Cuts tab in the control window. This tick indicates that we're already applying a threshold of 1.0 GeV on the transverse momentum. That's the momentum of each track pointing away from the beam pipe. If we didn't have that, the view would be even more of a mess. If we're looking for photons or electrons that have come from the decay of a heavy particle, like a Z or a Higgs, we would expect those to have quite a large transverse momentum. So we can increase this threshold from 1 to 5 GeV, and we're probably not going to get rid of anything that's very interesting to us. There are still some charged particles left here, but it doesn't look like they're pointing anywhere near the energy deposits, which would suggest these are probably from photons and not from electrons or positrons. Let's zoom in on the side view as well, and here too we can see that there's an energy deposit here and one here, but they're nowhere near the charged particle tracks. So we want to flag these as photons, but we can't do that by selecting the relevant tracks because they haven't left tracks. So what we do is we switch to the Physics Objects tab here, and if I zoom out, you can see that this has added two large objects here, which the computer has reconstructed from these energy deposits. So in fact we can select those by using the Select tool. If we go to the control window and choose this finger icon, we should then be able to select the objects here. If that doesn't work, we can try just selecting them in the detail view here. Click object 0 or object 1, and you can see that the corresponding object is highlighted in the detector view in the canvas as well. So let's select object 1 and say that we think it's a photon by clicking on this box here. Then let's go to the other object and click photon. Now let's have a look at the invariant mass window and see the objects that we've just added. They have a combined invariant mass of 137 GeV. So that means that if these photons came from an object like a Higgs that just decayed into two photons and nothing else, then we can say that that object they came from had a mass of about 137 GeV. Well, that's in fact a little bit larger than we now know is the mass of the Higgs boson, but most of the photon pairs we find don't actually come from Higgs at all, and we have to look through a lot of events and plot a histogram of all the reconstructed masses to actually find the small excess, which is the sign of the Higgs boson.